Going through the questions from the Mechanics M1 paper from the Cambridge 9709 syllabus. This is October-November 2023, paper 4, variant 3, the M1 paper. And this question here, or this paper here, is shorter than the P1 paper. It's 1 hour and 15 minutes. And it's worth less marks, worth 50 marks as opposed to 75 marks. All right, so there's a few different things we have to be sure of before we start. Things which are important, for example, you must show all necessary working clearly. No marks will be given for unsupported answers from a calculator. So, for example, when you have to factorize to solve a quadratic equation, for example, you have to show that you factorized or used a formula or completed the square. You can't just write the answers from the calculator. For example, things like that. Give non-exact numerical answers correct to 3SF, or 1 decimal place for angles in degrees, which is the same as what we learned in, for example, IGCSE. And the important one here, which is not the same as some other boards like Edexcel, is that we use 10 for G, 10 meters per second squared for the value of G. In some other examining boards, they use, for example, 9.8, 9.81. But in the Cambridge board, we use 10 as our value for G. Okay, so that's important point there. Okay, so now in these questions that I'm going to go through, I'm going to go through them one by one, save each one in a separate video, so I can classify them in playlists dealing with the paper and other playlists dealing with the topic to make it easy for students to, basically if they're looking for the paper, they can go to the paper playlist. If they're looking for questions dealing with a particular topic, and kind of watch different questions on that topic, they can go to the playlist dealing with the topic. That's the reason why I'm doing that. And also, I'm not just going to be like a talking mark scheme. I'm just going to write down exactly what it says in the mark scheme and not explain. Sometimes I might go into some detail. Sometimes I might explain some background to certain things which students normally ask me about. When I'm doing these questions, sometimes it's because I've marked a paper of some of my students and I've seen certain common errors, certain things that I want to highlight to students, or certain students have asked me questions about a particular aspect of a topic. So I might sometimes go into some detail on that aspect. So sometimes I go on a bit more than you might expect for me answering the question. And that's the reason being because I'm trying to use this as a teaching tool for my students, but I am sharing this on the YouTube platform for other students to watch. Okay, so don't just think, oh, why is he taking so long, whatever. I have my reasons for taking my time certain times to make sure that my objectives are fulfilled. So let's start now with question number 1. Now, question number 1 is a question about vertical motion under gravity. All right, so it says a particle is projected vertically upwards from a horizontal ground with a speed of u meters per second. The particle has a height s meters above the ground at times 3 seconds and 4 seconds after projection. Find the value of u and the value of s. Okay, so you have the situation where something is projected from a level which we're going to call, for example, we can call it O. So I'm going to call this level O. I'm going to make a little line here. This is the starting point O. This is where we're measuring everything. And it is projected upwards with a speed u, meters per second. All right. Now it's going to go up and then it's going to come down again. So it's going to go up vertically and then it's going to come down again. So it's going to go up, reach its highest point. It's going to come down and hit the ground again eventually. All right. Now there's a time when it reaches s meters above the ground. So I'm going to make this line as s meters. Okay, so this is s meters. So this distance here is s meters. From there to there, I'll call this s meters. Let me call this the point A above the ground. Okay, level A above the ground, that's s meters. Now, you see what's happening? It's going on the way up. It's going to reach this point here, and it's going to reach this point again on the way down. Now, S, remember, stands for the displacement. It's not the distance traveled, It's displacement, how far out of position the object is. And that's something really important for us to understand. Okay, that a lot of students, they miss that, and they have problems with this question. S stands for how far something is out of position. So at these two times, which we know are when time equals 3 seconds, so time equals 3 seconds, it's going to be reaching A on the way up. And when time equals 4 seconds, it's going to be reaching A on the way down. Okay, so it's going to go up, passing through that point, which is S meters away from O, the way up, and then again 1 second later, it's going to be coming down at that same level. Okay, so that's what this is referring to. Now, we have to find the value of U and the value of S. Okay, now we're dealing with constant acceleration due to gravity, and therefore we can use the Suvat equations. Now, there's two ways we could answer this question. I'm going to show you both ways. One way is we can consider A as the object is moving upwards, and we can consider A as the object is moving downwards. Okay, A as the object is moving downwards. All right, now, because initially this object was projected upwards, I'm going to take the upwards direction as positive. So this is my positive direction. So when I put my values for Suvat, so SUVAT stands for the Suvat equations. Okay, Suvat values. Okay, so S stands for the displacement, which we've called S. U is the initial velocity, which we've called U. V, we don't know what it is, but on the way up, it's going V upwards, so we're going to call it V. We don't actually have to need it. We don't need it in the question, but just for our, to fill in the values. Now A, because acceleration always acts down towards the ground. Okay, the value of the acceleration in our situation is acting down, and we've taken up as positive. It's going to be minus G, okay, which is minus 10. Take it as minus 10. And T, we know on the way up, that's 3 seconds. Okay, now on the way down, our S is going to be our S, our U is going to be our U. Oops, our U. Now I'm still taking up as positive, even though it's going down, because that's how it initially was thrown. Okay, but I'm looking at the situation when it's on the way down. Now, when it's coming down, the velocity is going to be going downwards. It's going to be V downwards, so it's going to be negative V, you could say. We don't actually need that. A is going to be, again, negative 10, because, as I said, we're taking up as positive and acceleration acts downwards. And T is going to be 4 seconds. Okay, now this up and down business, a lot of students have problems with that. Okay, but you have to understand what I do always is I'm taking, because this is from O to A, you can say A1. Let's say A1 is here and A2 is there. And this is from O to A2. The direction I take as positive is the direction it was moving where I start, which is at O. That's the direction I'm taking as positive. How was it moving at O? It was moving upwards. Okay, it started from here. After 3 seconds, it got to there. After 4 seconds, it got to there. Okay, so always take that direction as positive. The direction it was moving in when it initially was thrown, that will make everything clear for you. Not everyone, you don't have to do that, but that's what I like to do in my questions to make everything clear. So from these, I can make two pairs of equations, which will then help me to, which we can then solve simultaneously. So we can see we need to have S, we need to have U, because we have to find S and U. We don't need V, okay? We don't know V, we don't need V, so we're not going to be able to use V. But we have A and T in both cases, S, U, A, and T. So the equation of motion, which you can find in your formula for Cambridge students, is S equals UT plus a half AT squared. That equation uses all the values that we need and that we have. So we can write an equation for O to A1, which is S equals U times 3 plus a half times minus 10 times 3 squared. And for O to A2, we can have S equals U times 4 plus a half times minus 10 times 4 squared. So from these two equations, we can then hopefully solve. So 3U, that's going to be minus 5 times 9, which is minus 45. S equals 3U minus 45. And here, S equals 4U. That's minus 5 times 16. That's going to be minus 80. Okay, that's 5 times 16 is 80. Good. So now we got these two equations. We can use substitution here. I can replace the s with 4u minus 80. So I can say 4u minus 80 is equal to 3u minus 45. So I'm going to have 4u minus 3u is going to be minus 45 plus 80. So that's going to be u is equal to, that's going to be 35 meters per second. And then we can find what s is. We can have s equals 3u minus 45. So s equals 3 times 35 minus 45. So s equals, that's going to be 90 plus 15, 105 minus 45. So s equals, that's going to be 60 meters. So those are the values of u and s, and we have answered the question. Okay, so that's one method of answering this question. There is also an alternative method, which is also quite easy, and that is to understand that because of the symmetry of this, okay, that it's going up and then it's going to go to the highest point, then it's going to go down again, that exactly halfway between these two times it's going to reach its highest point. At t equals 3.5, halfway between 3 and 4, that's where it's going to reach its highest point, where its final velocity will be 0. So if I call this point, for example, B, okay, I can consider from O to B, and we can put our SUVAT values in, and that will help us. So S we don't know, U we don't know, V is 0, A is minus 10, and T is 3.5. So we can find what U is. The S that we find here is not the S that we're looking for. This is a different type of S. This is, I'll call it S dash. This is not the S that we're looking for. The S we're looking for is this S over here. The S referred to in this is now the highest point, which is not what we're trying to find. But we can find U from this. And we know that we can use here V equals U plus AT. So V is going to be, 0 is going to be equal to 0 is going to equal U, which is we have to find, plus minus 10 times 3.5. So you have 0 equals U minus 35. So therefore U equals 35 meters per second, which is what we found. And then we need to find our S. So we can now look at O to A. So it's a different situation now. Our S is what we have to find. Our U is 35. Our V, now we don't know. Our A is minus 10, and our T, let's look at the first situation when it was 3 seconds. We can look at that, and that will help us find what S is. So now we can find the value of S. So we have S, U, A, and T. So we can say S equals UT plus a half AT squared. So we can say S equals U, which is 35, times T, which is 3, plus a half times A, which is minus 10, times 3 squared. So S is going to be 3 times 35, which is 105. That's going to be minus 5 times 9, which is 45, 45. That gives you 60 meters. So we say S equals 60 meters. So we get the same two answers. And we can even verify that even if I used T as 4, it should give us the same answer, which I'll just use a calculator for. Okay, what's happened there? Something weird. Okay, so if I put 35 times 4 minus 5, that's a half times minus 10 times 4 squared, which is times 16. And you can see that gives us 60, the same answer. So whether we use T equals 3 or T equals 4, it gives us the same displacement because that's the displacement at 3 and 4 seconds. Okay, so we get the same answers. Both of those are perfectly fine. This one involves a bit of simultaneous equations. This one doesn't. This involves having two separate kind of situations for SUVAT. This can just deal with one situation of SUVAT, basically. So there we have the answer to question number 1, which is all about vertical motion under gravity. Some very, very important points here. Direction, the meaning of displacement, okay, are very key in this question for us to understand. So there's the answer to this question. Other questions from this particular paper can be found in the playlist that will appear in this section over here at the end of this video. Other questions from the topic of vertical motion under gravity from my Cambridge works can be found in the playlist over here. I will also include my vertical motion under gravity for my Edexcel collection, where you have to just be a bit cautious because the value of G there is 9.8, but the principles are basically the same. And you can subscribe to my channel by clicking on this link. Thank you for watching and see you soon.